Probability. In this lesson, we shall explore more about probability, and more specifically, how we calculate the likelihood of something happening when we know the likelihood of something else happening. Well, we should remind ourselves about some of the basics of probability, and let's do so. Probabilities are given values between 0 and 1. We should know that. The chance of something happening ranges from 0, which means impossible, or 1, which means certain. If we say that something has a probability of happening equaling 0, it means that it is impossible. And if we say that something has a probability of happening equal to 1, it means it is certain. And anything in between can happen, but the closer we get to 1, then the closer we are to certain. And the closer we get to 0, the closer we are to being impossible. Now, of course, we know that when we speak of numbers between 0 and 1, pay close attention, then we're speaking of fractions, and we know that we could express a fraction as, for example, 4/5, right? 4/5, 4 out of 5, that's closer to 1, because 5 out of 5 is 1. So if I said that the chances of something happening were 4/5, then you know that it's getting closer to 1. We could express this same quantity as a decimal, which would in this case would be 0.8, and we know that 0.8 is closer to 1 than it is to 0. So it is something that is quite likely to happen. And of course, we could express it also as a percentage, 80%, which is 4/5. 0.8 is also the same as 80%. And the important learning here is that they all are between 0 and 1. So have a look at this question here. When you toss a coin, what is the probability that it lands heads up? Well, we know already that the probability of getting heads is 1/2. This is nothing new because there's only two things that can happen. So we know that the probability of getting heads plus the probability of getting tails equals to 1, because you are certainly going to get either heads or tails. But because they're both equally likely to happen, then we know that this must be a half plus this must be a half, because half plus half gives us 1 whole. So if we understand that, we should understand that probabilities always add up to 1. All the things that are possible to happen must equal to 1. And let's explore this a little further. So here we have a question that tells us the probability that it rains tomorrow is 2/3. What is the probability that it does not rain tomorrow? Well, tomorrow it must rain or must not rain. It will either rain or it will not. And we are already given the fact that it will rain to be 2/3. So when you take the probability that it will rain 2/3 and you add the probability that it won't rain, which we don't know at the moment, it must equal to 1, because it will either rain or not rain. So then, we can just use our algebraic understanding, which means that the probability that it will not rain will equal 1 take away 2/3, which equals 1/3. So if the probability that it will not rain is 2/3, that it will rain is 2/3, then the probability that it will not rain will be 1/3, because the two of them, the probability that it will rain, 2/3, plus that it will not rain, when you add them together, you must get 1. So if you understand that, it means that if I tell you, or if you're being told that the probability of something happening is so much, then the probability of it not happening or something else will happen, when you add them together, you must always get 1, because 1 is the certainty of something happening. Let's do one last question for ourselves. If I tell you the probability of the bus arriving on time is 0.7, then the probability of the bus arriving late will be 0.3, because when you add the two together, you get 1. And how would you work it mathematically? You know that certainly the bus will come or will not come on time. So 1 take away the probability of it being on time will give you the probability of it being late. So that's how we work it out mathematically. That's the understanding. And we normally speak of probabilities by writing P, then opening a bracket, probability of being on time, equals 0.7. So the probability of being late will equal 1, take away 0.7, which equals 0.3. Well, I hope you understand that. And if you do, the best way to test and the best way to know is for us to have a go at some questions.